Leetcode 1201 ugly number 3. The problem is that write a program to find the nth ugly number. Ugly numbers are defined as positive integers which are divisible by a or b or c. Here the example we have n equal to 3. We have a, b, c equal to 2, 3, 5. We have to find the three's number that are divisible by these three numbers. So the ugly numbers are 2, 3, 4, 5, 6, 8, 9, 10. The third number is 4. And we can continue to see another examples. N equal to 4, and this ugly number is fourth ugly number is 6, and here the fifth ugly number is 10. And we have this range 10 power 9. This is very large, so it tells us we cannot use a linear program to solve this problem. Because the 10 power 9 is huge, will be cause TLE if we use the ON time complexity. So for the naive method, it doesn't work. Naive method is to try to generate all the numbers from 1 to m, and the m is bigger than n, and we check each number that is divisible by the a, b, or c. If it is, we put into the answer until we find the nth number. That takes OM time or cost. It is what we are called TLE. A second solution that we have found that we have found the numbers of divided by a, b, c. We can generate the numbers 1 times a, 1, 2, 3, a times 8, and then until n numbers. Here n times a, and then hold 1 times 3 times b, 2 times b, 3 times b, n times b, and 1 times c, 2 times c, 3 times c, until n times c. And in this is like we have generated 3 sorted list, but each list length is on. So each time we fetch the first number is from this each element of the list. So here first we fetch the a, b, c, and after a, we then check which one is smaller. If a is first list is smaller, then we fetch the second 2 times a. So it's like we merge the case sorted list until we find nth numbers. So in this problem is also takes ON time probably took ON and log n time if we use heap to find the nth numbers. So it also will cause TLE. And then with third method we have to consider the optimize again. So how do we optimize that? And if we can quickly to search. And for example, we search numbers m. If m is divided by the a, b, and c. If m is we have found the how many numbers that is could be divisible by a and b, c. If we call a function, and the function is count, and if the count is bigger than n, that means that we have to go to left to find again. So if it's smaller, and we should go to right interval. So this way that it reminds me of the binary search. So for if we use binary search, the critical idea is how do we find the nums, the number of the numbers, the number of the nth value that could divided by a, b, and c. And we have, for example, we have defined f num equal to the number of a. If we divide the number of a, this means that the number of values that could be divisible by a, that is smaller than num, and thus we could also check the number of nums that divided by a and also divided by c. When we get this plus these three together, we have something overlap over here. It's like that. For example, in this circle here, we have the number divided by the number of the values that could be divisible by a, and this is divisible by c. This a, this is b, and this c. Say if we find a number that could be divisible by a or b or c, by the three of them, that means that we have to find this common all the numbers that is over here, this over here, or over here, and plus here, plus here, and here. So of course plus here, but when we get the numbers, number over a and also number over b. For number over a and number over b, when we plus together, we will have the overlap calculation. So we have to get the numbers that could divisible by a or b, and also if we add the number of divided by c, we here to divide it by the ac minus number of the b and c. But here is that we have, because we have divided 3 times, divided once more time by this common area here. The common area is over here, this common area. So we have to plus this one common area here. So and this is basically the functions. If what happened? This is a function that f_num equal to this. This means that the number of the values that is divisible by a or b or c here. And another is that how do we calculate this a and b divisible by a or b? We could define a least common divisor. The least common divisor. The least common divisor is that means that the numbers L, C, D, A, and B. That means that numbers could be divisible by A, and also could be divisible by B. So it can calculate from the LCD, from calculate the great common divisors. Great common divisors, I think, is very common to lots of guys. If we can use this A times B divided by the great common divisor. Great common divisor is we can use a library, or we can implement by ourselves. And so after we figure out, then we use the logic of this binary search tree logic here. So logic, and to find out the quickly. So this time complexity should be probably so log m times. How that m is that the largest values range we need to search. And in this example, we use m equal to 2 times 10 power 9. That is enough. And the space complexity is basically 01 here. So then we write the code here, and we can define the great common and set this divisor. And we get the least common we get the least common divisor, LCD. For any two, it will return A times B divided great common divisor AB. Then we use the binary search, so we can get the each two numbers least common divisor first. We start from 1 to the largest is 10 power 9. So when we use the recursive way to implement the binary search here. if count bigger than n, we go to the left, and others we go to the right. So we return the I here. Okay. Yeah, we made it.